Alright people, so welcome to Jumbo IS and welcome to our lecture series on current affairs. Now we are performing weekly current affairs regimen. Okay, so in this lecture series we cover 1 week's current affairs in one lecture, that too catering to one particular subject. Today we are going to cater to geography and environment. So the past 1 week, whatever developments have happened with respect to the field of geography and environment, we shall cover in today's lecture. Okay, now let me tell this to you in advance because I say this every time. Let me say it again. The thing is that just watching this lecture would be job half done, because just after watching it, you need to revise it as well. Why? Well, revision helps in consolidating these current affairs in your memory. Otherwise, you'll quickly forget them. Now, you can revise these current affairs from the notes provided by us, and these notes shall be shared on our Telegram channel. The link to our Telegram channel is provided in the comment section below this video. Okay, so please do not forget to revise. Otherwise, these current affairs would be of no use if they are not part of your memory. Okay. All right then. Enough of the introduction. Let's straight away dive into the lecture. So let's begin. So current affairs, geography and environment, June, part 1. So let's take a look at the topics. So number 1, we are going to talk about active dust storms that are happening, that are plaguing North India. In North India's colloquial language, these are known as Andhi. So what geographical factors are behind these active dust storms? We'll talk about this. Then we'll talk about isobutanol diesel blending mandate. We all know about ethanol blending program, but ethanol is blended with petrol only. For diesel, the government is coming out with guidelines and a framework with isobutanol. So government is basically now trying to blend diesel also with another biofuel. So we'll talk about biofuels as well through this lecture. Okay. Then the next topic is with respect to Majuli Island, the largest riverine island in the world, found in the state of Assam. So we'll talk about this. Then we'll talk about a traditional tribal technique for rainwater harvesting, known as the Halma tradition in Madhya Pradesh. And in the end, we'll talk about a topic which is related to a little bit of history. How Mauryan administration basically used science for rainfall measurement. And this rainfall measurement system that they had, the Mauryans had, basically that helped them to design their agricultural taxation policies as well. So they were pretty scientific, and this scientific rainfall measurement system is also mentioned in Kautilya's Arthashastra. So this is really important for us. So we'll talk about this fascinating topic as well. So these are the 5 news items that we shall zero in our attention on. So let's start discussing them one by one. Starting with topic number 1, and that is active dust storms, Andhi. Now, North India generally, just before monsoons, in the pre-monsoon season, receives these very gigantic, big, very destructive dust storms. Okay. Now, the reason for that is because of intense heat and creation of low pressure systems, these dust storms are created. But this time around in these summers, these dust storms have become number 1, more frequent, and number 2, more intense, which tells us that there is another geographical factor at play apart from the low pressure systems created by intense heat. Okay, so what are the geographical factors behind these dust storms which have become more frequent and intense? We'll talk about this, and we'll also talk about the impact of these dust storms. These dust storms do not have any positive impact, all negative impacts, but we need to be aware of these negative impacts as well. So let's talk about these active dust storms in the pre-monsoon season of northern plains, okay, which are colloquially known as Andhi. All right, then, let's begin. So active dust storms, Andhi. So what was in the introduction? During late May and early June, northwest India, specifically Rajasthan, Haryana, Delhi, NCR region, witnessed high-intensity, multi-day, severe dust storms. This anomalous pre-monsoon activity was driven by powerful western disturbance that extended deep into lower latitudes, colliding with highly localized thermally induced low pressure systems over Thar Desert. Now, the second statement might seem a little complicated, so let me simplify it. Okay, the second statement basically means that the reason why these dust storms have become more frequent and intense is because of 2 reasons. Number 1, the usual suspect, low pressure systems in northern plains. Okay, and these low pressure systems are thermally induced. That means it's because of intense heat. Now, this is the usual suspect. Now, what is unusual this time is western disturbances. Western disturbances generally is a phenomena that is reserved for winter seasons. These western disturbances bring a lot of rainfall during winter months of North India. Okay, they also bring snowfall to the Himalayan region. But this time around, western disturbances have carried on till the month of May and June, deep into summers as well. So this has basically accentuated the intensity and frequency of these dust storms. So let's talk about these two factors one by one. First, let's talk about western disturbances. What are they? And then let's talk about these thermally induced low pressure systems. Okay. So first, let's talk about western disturbance. So what are western disturbances? These are extratropical cyclones, storms, or low pressure cyclones that originate over Mediterranean Sea in Europe, Caspian Sea, Black Sea in the Eurasian landmass. And then these extratropical temperate storms, they travel eastwards, okay, southeastwards towards the Indian subcontinent. Over here, they meet Himalayas. And once they meet Himalayas, they get bifurcated because of the tall height of Himalayan mountains. They get bifurcated. One branch in the north goes towards Tibetan Plateau, and the other branch enters the northern plains. Now, since these extratropical cyclones originate in these seas, they carry a lot of moisture. They bring the much needed winter rainfall in the northern plains and the snowfall in the Himalayan region, which feeds into various northern rivers. Right? This is the normal thing. And this phenomena generally takes place during the winters. Okay. Now, the reason why these western disturbances travel eastwards is because of subtropical westerly jet stream. Now, what is a jet stream? Well, basically, jet stream is nothing but upper atmosphere circulation. These are winds blowing at an altitude of 10 to 12 kilometers. So these cyclones, when they form clouds, they go upwards, and over there in the upper atmosphere, winds are blowing in the eastern direction. They carry these clouds towards India. So this is what is happening. Now, generally, as soon as the winter season ends, the jet stream moves northwards in the northern latitudes, and therefore these western disturbances also move north of Himalayas towards Tibetan Plateau entirely. But this time around, western disturbances are still blowing across northwest India. Okay, so this is the basic reason. This is an anomaly. These western disturbances are absent during the summer season in India, but they have still carried on, extended till the month of June. Now, what is the second phenomena? Pre-monsoon dust storms, Andhi. So, Andhi is a regional term for convective high-velocity local dust storms common to Indus-Ganga plains during the pre-monsoon months. Now, they are thermally induced. How are they thermally induced? What are they basically? So, what happens is that, well, intense heat, intense solar radiations are basically, well, northern plains are being subjected to this intense heat. This basically heats up the air close to the ground. When the air becomes hot, it rises upwards. It rises upwards very quickly. It creates a low pressure. Therefore, nearby winds are moving towards this low pressure area at very high speeds. Now, what happens is, if this hot air carries some moisture, goes upwards, forms clouds, cools down, and sometimes brings rainfall. But once it cools down, it descends downwards very rapidly. This is known as the downdraft. And this downdraft basically erodes the top layer of the soil. If the top layer of your soil is dusty, as the case is in Rajasthan, well, it blows off that dust because the wind moves with very high pressure downwards. Okay? And it blows off that dust, and then that dust, you see that dust storm basically. Clear? So this is what is happening. Now, what happens when western disturbances also join these low pressure, thermally induced low pressure systems? So, step one, there is a 4-step process. So, step one is these low pressure systems. Step two is western disturbances. So, what happens is that, well, hot air rises up, it cools down, and then another layer of cool air is being carried through western disturbances. So, there is a very high pressure in the upper atmosphere. That is why the cool air in the upper atmosphere descends downwards. The downdraft is very severe. And because that downdraft is very severe, dust rises very intensely, and the dust storms are very intense. This is what is happening in step 3 and step 4. Basically, Long story cut short. Now, in your notes, I have also given this table which shows the difference between western disturbances and pre-monsoon Andhi. Okay, so do check it out. Western disturbances are from December to March. Well, Andhi is May to early June. This is summer, this is winter, this is cold, this is extremely hot, this is widespread mountain snow. It brings snowfall. It only brings rainfall in the northern plains and other things. Now, remember I told you in the beginning that there are only negative consequences of these dust storms. So what are the negative consequences? Severe, and northern India is suffering from it. Number one, desertification. Because these dust storms blow up the top layer of the soil. Top layer of the soil is fertile. So it causes soil degradation in these agricultural regions. Rajasthan, some parts of Punjab and Haryana. So this is a problem. Then these dust storms also increase particulate matter 10 and particulate matter 2.5, basically harming air quality, increasing air pollution. Delhi is already suffering from air pollution, so this accentuates the problem. Then this dust gets deposited on solar panels. Okay, once the dust gets deposited on solar panels, well, it harms the efficiency of these solar panels because, well, it hinders sunlight that is basically hitting these solar panels. So the efficiency of solar panels also comes down. And these dust storms also bring in some disasters like blowing of trees, uprooting of trees, damaging electricity grid. So these are the negative consequences of these dust storms. That's about it. All right. And now let's quickly move on to next news item, and that is isobutanol diesel blending framework. Look, India follows ethanol blending program with respect to petrol. Okay, now there is some controversy regarding this issue because people have complaints that this ethanol blended petrol is harming their engine quality, car engine quality. Okay, but that is a separate debate. The reason why we use ethanol in petrol, well, there are two reasons. Reason number one, this reduces the demand for petrol, and you all know that we are import dependent as far as petroleum is concerned. So this reduces our import bill a little bit because ethanol is locally produced. So if 20% of your fuel tank is composed of ethanol, then demand for petrol would come down by 20%. So that was the reason. This is reason number one. Reason number two is to lower greenhouse gas emissions. Okay, because ethanol, when it is burned, does not release that many greenhouse gases as burning of petrol does. So climate change and reducing import bill, these were the two reasons. But ethanol cannot be blended with diesel cars, diesel trucks, diesel buses. So we had to find a way out to reduce our import bill on diesel as well, to reduce greenhouse gas emissions from diesel vehicles as well. So now we have found a fuel called isobutanol that properly blends with diesel, and the government is now framing guidelines to blend isobutanol with diesel. Right? This is the issue. So let's talk about it. So isobutanol diesel blending framework. So what was in the news? So Ministry of Road and Ministry of Petroleum issued structural guidelines to phase in isobutanol diesel blending framework in India. Okay. Now remember, these fuels, isobutanol, ethanol, these are called biofuels. Why are they called biofuels? Because they are derived from biological living organisms. In this case, plants. Okay, ethanol is created from plant material. Isobutanol is also created from organic waste. So that is why we call them biofuels. And biofuels are important because they can be locally produced, so no import dependence. And biofuels also do not emit that many greenhouse gases as petroleum burning does. So that is why we are using biofuels. Okay. Now, why are we choosing isobutanol over ethanol? Very simply put, well, ethanol can only be blended with petrol. So what about diesel? Well, for diesel, we have isobutanol. That is the precise reason. Plus, isobutanol has certain other advantages which makes it a superior biofuel than ethanol. Okay, what are those advantages? Number one, it has high energy density. More energy per gram of this fuel. Okay, 82% of energy density of pure diesel, whereas ethanol has only 60% of energy density of petrol. So it is better. Then it has low moisture absorption. Basically, ethanol has this one particular problem, and that is that ethanol is hydrophilic. That means it attracts and absorbs H2O. Now, water in your fuel tank corrodes your engine. But isobutanol is hydrophobic. That means it repels H2O. So no water in your fuel tank, no corrosion of your engine. Clear? So this is there. Then ethanol basically corrodes the rubber gaskets or fuel lines also. So if you're transporting petrol through pipelines, they corrode the inner structure of the pipelines because ethanol is corrosive, but isobutanol is not. Plus, high vapor pressure safety. Ethanol has low vapor pressure, which means that it does not evaporate that easily. Whereas ethanol evaporates very quickly during summers, during high temperatures. But isobutanol does not evaporate that quickly even when the temperatures are high. So it's pretty useful during summer months in India. Plus, there is another added advantage. You see, biofuels have different generations. First generation biofuels, second generation, third generation, fourth generation. The reason why we use biofuels is because they do not emit that many greenhouse gases. First generation biofuels emit a lot of greenhouse gases. Second generation biofuels emit less amount of greenhouse gases. Third generation biofuels are carbon neutral. They do not emit any greenhouse gases net. And fourth generation are carbon negative. In fact, they absorb greenhouse gases, the entire process. So fourth generation is the best, but India currently lacks the technology to mass produce third and fourth generation. Now, ethanol is first generation. Okay, but isobutanol is second generation, so it emits lesser amount of greenhouse gases. Okay, first generation biofuels are generated from food crops, so there is this food versus fuel debate also. Second generation are created from organic waste, third generation from algae, fourth generation from genetically engineered crops. Okay, so this is the thing. Now, this second generation biofuel has many advantages. Isobutanol, it is classified as an advanced second generation biofuel. Now, this second generation biofuels are created from organic waste. Isobutanol is created from organic waste like corn stubble, rice straw, sugarcane bagasse, all are waste products. Okay, so this is a good thing. No food versus fuel debate. Plus, remember this thing. You don't have to remember this entire paragraph. Just remember that isobutanol is created from organic waste using a technique called ABE fermentation or acetone butanol ethanol fermentation. Just remember this term because an MCQ can be asked. That's about it. Okay. Now, there are some core challenges with isobutanol as well. We have discussed the advantages of isobutanol, but isobutanol has some challenges. First of all, cetane number. Higher cetane number means that it is difficult to ignite that fuel in the engine. Diesel has higher cetane number. Isobutanol has lower cetane number. Now, this difference in cetane number, which might create differences in temperatures that are required for ignition, makes blending these two fuels a little difficult. So this is a problem. Plus, our biorefineries, our fuel refineries already have ethanol related machines. Now you want them to retrofit isobutanol related machines. It will be a logistical challenge. Plus, it is costlier than ethanol. So these are some of the challenges, but the advantages outweigh the challenges. Therefore, the government is going ahead with this. Right? Simple. Okay. Now let's move forward to third news item, and that is related to Majuli Island. Now, first of all, you need to know what is a Majuli Island. What is this Majuli Island? So what is an island? Well, island is a landmass surrounded from all sides by sea, right? Now, oceans, seas are capable of creating islands, but rivers also create islands. Now, some of these riverine islands are so big that, well, people live over there. Okay. The biggest, the largest riverine island in the world is Majuli Island of Assam, which is created by Brahmaputra River. Okay. Now, the reason why this was in the news was because certain geologists and climatologists studied 4,000-year-old history of this island. Okay, the 4,000-year-old history of the plants on this island, the climate that this island basically was subjected to, all this. Now, that entire 4,000-year-old study is not important for us. Okay, what technologies were used in that study, that is also not important for us. Though I've mentioned that in your notes. But questions would be asked with respect to Majuli Island. Okay, certain specific facts related to Majuli Island, okay, the culture of Majuli Island. So in this lecture, we'll focus entirely on that. Geographical location of Majuli Island. So we'll focus on this. Okay, so let's talk about this. So Majuli Island. So the reason why it was in the news was because Indian geologists and global paleoclimatologists. Paleoclimatologists means climatologists that study the climate of, historical times. Okay, they came out with a history of climate in Majuli Island. But this is this Majuli Island. Okay, it is found in Assam, formed by Brahmaputra river, and a lot of silt that is carried by Brahmaputra river sediments. It gets deposited on this island, and that is why this island is a landmass. Clear? Now, you need to know, because location based MCQs are also asked, so you need to know the location as well. So this is Brahmaputra river. Okay. Now, the northern channel of this Brahmaputra river is known as Kherkatia Suti river. It is joined by another tributary of Brahmaputra, Subansiri river. So the lower channel, the southern channel is Brahmaputra, the northern channel is Kherkatia Suti river, which is joined by Subansiri, and then it joins again into the mega Brahmaputra river. Clear? So on north is this river, on south is Brahmaputra, and on north again is Subansiri river. Clear? Location is very important. Other facts about Majuli Island. So it is officially recognized as the world's largest inhabited river island. People live on this island. Plus, it was declared a separate district in 2016. It has a separate DC and all. It is dynamic fluvial landform formed by Brahmaputra river system. Okay. It is also vulnerable also because Brahmaputra river constantly shifts courses. So it is being eroded. Flooding is a regular thing over here. So this is a problem. Okay. Now, what is the significance of this study that was conducted? Number one, well, it informs us about, well, the climate of the region, the weather. If we are aware of the historical weather phenomena in this area, it would lead to better flood management. Because Brahmaputra shifts courses quite rapidly. Okay. And then, well, one significance about this island also. Well, as far as the culture, religious culture of this area is concerned, it was basically influenced by the Neo-Vaishnavite movement in the medieval times. This Neo-Vaishnavite movement was spread by a Bhakti saint, Bhakti Sufi, Shankar Deva. And he popularized Vaishnavism in this area. And that is why this region has a cultural dance also, known as Satariya, which is a cultural dance depicting all the leelas of Lord Krishna, his life stories. They are depicted through dance. Okay. And well, the dancers also wear masks. So those masks are also very popular. Some have GI tags also. So Satariya, it is popular for Satariya, Neo-Vaishnavite movement, Shankara Deva, the Bhakti saint. Remember these three terms because culture-based questions are also asked, right? And that would be all. Now let's move on to next news item, and that is Halma tradition. Now look, here's the thing. You see, there are many arid regions in India, and those arid regions are arid because number one reason is weather, climate. Okay. Number two is poor water management. Those arid regions lack water, but they won't lack water if they manage rainwater properly, right? For that, they need rainwater harvesting. Now, there are certain modern rainwater harvesting techniques. Now, those modern rainwater harvesting techniques have been applied, but they haven't been that efficient. Therefore, well, people are looking towards the traditional, ancient, cultural rainwater harvesting techniques. And in Madhya Pradesh, there is this particular tribe called Bhil tribe. They have gone back to their own traditional customs related to rainwater harvesting to preserve water in that area. Okay, that tradition is known as the Halma tradition. Now, the reason why we are studying tribal rainwater harvesting techniques is because sometimes modern techniques are not applicable to certain regions of India. Okay, over there, centuries old traditional techniques work. Therefore, Indian policy should be about, well, incorporating these traditional techniques in water management along with modern techniques. So we can learn a lot from them. Plus, these traditional techniques involve people participation, which is always a very good thing. That is why we are studying Halma tradition. So let's talk about it, okay? So Halma tradition. In response to severe pre-monsoon water scarcity in central area, indigenous tribal communities like the Bhil community across the Jabua and Alirajpur districts of Madhya Pradesh mobilized to revive their ancient community water harvesting custom known as Halma. This is how Halma looks. So you dig basically trenches, contour trenches. So rainwater is coming down from here, it gets accumulated in these trenches. Okay. And once the water gets collected in these trenches, it percolates into the soil, improving groundwater recharge. So this is how it's done. Okay. Now, what are the cultural roots of this tradition? The Bhil tribe. Halma is a foundational cultural tradition of Bhil tribal community and its subgroups like Bhilala and Patela. The philosophy of interdependence. In the Bhili language, Halma represents a formal mechanism for collective altruism. Collective altruism means that everyone is coming together for the benefit of everyone. Okay. So, and people do this labor of digging out trenches. People do this labor free of cost. That is why it is called collective altruism. They call it Shramdan, donation of their labor. Okay. And this Halma tradition actually saved a particular region which was suffering from water scarcity. It was the Hathi Pawa Hills in Jabua district. So this technique works also. Now, if there is a mains question with respect to modern rainwater harvesting techniques and traditional rainwater harvesting techniques, basically asking you to compare them, then this table will be really helpful. Comparison between state-led engineering irrigation techniques like dams and canals and the Halma framework. Halma framework is better because state techniques or these modern engineering techniques are high cost. Halma technique is low cost. This requires land acquisition, displacement, habitat fragmentation, okay, which harms the environment. These techniques are eco-friendly. These techniques, modern techniques, require high asset management, okay, asset maintenance, bureaucratic red tape. This is community participation. People are participating in it. So modern techniques have bureaucratic inefficiencies. This has people participation. So in a sense, there are certain advantages with respect to traditional techniques. We should follow it. Okay. And the Indian government can learn a lot of lessons from this. What are the lessons learned? Convergence with Jan Andolan. Government is already running various water harvesting schemes like Jal Shakti Abhiyan, Catch the Rain campaign, Mission Amrit Sarovar. And the success of these schemes depends on, the government has admitted it, success of these schemes depends on people's participation, people's movement, also known as Jan Andolan. So we need to incorporate the lessons from Halma technique in these schemes also. Plus, this Halma framework and many such frameworks for other tribals. Well, this is an example of decentralized climate resilience. Top-down approach is not better. Decentralized approach is always better because it is created in the context of local conditions, local environment, local requirements. So always be decentralized when it comes to such developmental schemes. Right? That's about it. And now let's move on to our last news item, and that is Mauryan rainfall management, the Drona technique. So generally it is believed that ancient Indians used to perceive rainfall as something divine. There was no systematic scientific way of studying that. That is not true. And the evidence for that, the scientific management of rainwater, comes from Kautilya's Arthashastra. Now, Kautilya was the advisor to Chandragupta Maurya. So basically his Arthashastra was applicable to Mauryan administration everywhere. And one such excerpt from Arthashastra shows that Mauryans were experts in rainwater management and rainwater measurement. And this measurement basically informed various policies related to Mauryan administration, policy related to agriculture, policy related to taxation also. Based on the rainfall that the area received, agricultural policies or taxation policies were designed, right? So what was this entire scientific thing? Let's take a look. Mauryan rainfall measurement, the Drona system. Okay. Now, for management of agriculture and taxation, Mauryans used to have a local officer called Sitadhyaksh. This Sitadhyaksh, his job was agricultural policy making and implementation. Okay. Therefore, this Sita Adhyaksh was sitting at the top of this system of rainfall measurement because rainfall is crucial for agriculture. Okay. Now, what was this system? Currently, Indian Meteorological Department measures rainfall. We measure rainfall, like we know that today we received 2 mm of rainfall, 100 mm of rainfall, right? So for that, IMD, Indian Meteorological Department, has rain gauges at different places, okay, where rainwater gets collected and you measure how much rainfall the area received. Similarly, Mauryans had Varshamana system. Now, what was this Varshamana? This Varshamana was nothing but a clay bowl that was strategically placed at different areas. This acted as a rain gauge. The Arthashastra records that approximately one rain gauge was deployed for every 10 villages. There were 1 lakh villages in Mauryan administration, so people have calculated that it had around 6,000 to 15,000 rain gauges. This is something that modern countries have, 6,000 to 15,000 rain gauges to measure rain properly. And now, today we measure rain in mm, 1 mm, 2 mm. Mauryans had different units. For example, based on the depth of water in those clay bowls, well, 12 mm meant 1 adhaka and 4 adhakas meant 1 drona. Okay, so that was the system that was followed. They had different units. Now, the reason why it got more scientific was Kautilya divided the entire Mauryan geographical region into 6 geographical regions. Okay, and he had targets for rainfall in each and every geographical region. Okay, so for example, if we are talking about desert areas, he said that if the rainfall is less than 2 dronas in desert region, we think there is going to be shortage of water, so this should be your agricultural policy. If it's more than this target, then there will be water surplus, follow this agricultural policy. So he divided the entire Mauryan region into 6 regions. Okay, Jungle region, dry semi-arid regions. Anupa, moist swampy regions, the Tarai regions. Okay, Asamaka, rocky stone heavy terrain. This is the modern equivalent of that. And he had targets like jungle region should receive 16 dronas of rainfall. If it receives less than that, follow policy 1. If it receives more than that, follow policy 2. So what were the examples of those policies? So Sitadhyaksha used early monsoon readings to instruct farmers on seed distribution. If initial rainfall was low, well, drought-resistant crops were distributed, seeds were distributed to farmers like millets, pulses. If rainfall was heavy, then labor-intensive wetland crops were introduced to farmers like rice and all, rice, sugarcane. Then even taxation was also based on this. If rainfall is extremely low, then some taxes were waived off. If rainfall was surplus, well, taxes were collected. They did not have any flat tax rate. Taxes varied with respect to rainfall. Plus, Mauryans ran many irrigation projects, right? And Mauryans, Kautilya prescribed strict punishment for anyone who damages any irrigation project. Like if there is a serious damage to a particular dam caused by a person, there was even death penalty because they realized that irrigation is crucial for economic upliftment of all the subjects in Mauryan administration, right? So this was the thing. We were very scientific back then. All right. That would be all. With that, we conclude today's session. So thank you so much for watching, everyone. And I'm sure it has added value to your preparation. But it would add more value if you're consistent and regular with this lecture series. Number 2, you revise this lecture from the notes provided by us. So in the hope that you're not going to forget that, I shall see you next time with another lecture in this lecture series of current affairs. Thank you, everyone.